So quadratic function is anything that's x squared. And an x squared graph is parabola shaped, so U-shaped. So we're going to be talking about polynomial functions a lot in chapter 2. Quadratic is just a specific type of polynomial. So polynomial, poly means many. So we're going to be dealing with many x's in our functions here. But in 2.1, we're just focusing on quadratic. So that's just x squared. So in the last chapter, we talked about lines. So lines have the equation of y equals mx plus b. Here we're going to talk about quadratic functions. So quadratic functions in standard form are a times x squared plus b times x plus c. So this is standard form. So the number in front of the x squared is your a, number in front of the x is going to be your b, and then the constant is your c. So quadratic functions are U-shaped curves that are called parabolas. So they can either open up like a smiley face or open down like a sad face. It says parabolas occur in many real-life applications, especially those involving reflective properties such as satellite dishes or flashlight reflectors. I like when they do examples with like throwing a football. Throwing a football is kind of parabola shaped, but upside down. So parabolas and quadratic functions happen often in real life examples. So all parabolas are symmetric with respect to a line called the axis of symmetry. So the axis of symmetry cuts our parabola right down the middle into two symmetric pieces. And the axis of symmetry is a line. It's a vertical line, so it is always x equals. On the next page, it talks about just basic characteristics of a quadratic function. So the left side is when a is greater than 0. So this is talking about a positive a. So if our leading coefficient is positive, our parabola opens up. So it's a smiley face. So when a is positive, your parabola opens up. The domain of our parabola is all real numbers, or from negative infinity to positive infinity. And then also when our parabola opens up, the vertex is at the minimum. So it's at the lowest point, which we have a minimum here. Now if a is negative, so if a is less than 0, we're talking about when it's negative. Now our parabola opens down, and our vertex is at the maximum. So here, when we have an upside down parabola or an upside down U, when our parabola opens down, our vertex is at the maximum, bless you. And then our domain is also from negative infinity to positive infinity. So it doesn't matter whether it opens up or down. Your domain is always, 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 for parabolas, all real numbers. Next page is just another example of when it opens up and when it opens down. In example 1, we're going to graph our parabola. So looking at 1a, I'm going to start by drawing my graph here. Now, since we have a negative in front of the x squared, do you think this is going to open up or open down? It opens down. It's going to be a sad face parabola. And then we're adding 1 on the outside. What type of transformation do you think happens when we add 1 on the outside? It goes up 1. Just up. Yeah. So our parabola is going to get shifted up 1. So instead of just being at 0, 0, we shift it up 1, and it opens down. So our parabola would look like that. Now, just for fun, what would our axis of symmetry be here? Not just 0, but x equals 0. That would be our axis of symmetry. Let's do B. So we're going to do the same thing. When we add 2 on the inside, which way does that shift our graph? To the left 2. Awesome. And then when we subtract 3, down 3. And here, do we think our parabola is going to open up or open down? It opens up. There's no negative out front, so it opens up. It's going to be a smiley face. So we're going to shift our parabola to the left 2 and down 3. So that would be our vertex. Now we're going to draw our parabola opening up. So it looks like this. Now here, what's our axis of symmetry? Awesome. X equals -2. We're going to practice a couple others, just so we can practice shifting them. So let's say, I'll say example C. If I had x plus 1 squared plus 4. When we add 1 on the inside, which direction does that move our graph? Left 1. If we add 4 on the outside, which direction does that move our graph? Up 4. Perfect. If you want to draw it, you can, but I just want to practice going over the shifts. So then for D, what if we have x minus 2 squared minus 3? Minus 2 on the inside moves our graph which way? Right 2. And then minus 3 on the outside? Down 3. Awesome. And for C, does our parabola open up or open down? Up. It opens up. There's no negative out front to make it open down. What about for D? Up. Same thing, also up. Next, we have another form for our quadratic functions. The textbook and on WebAssign, we'll call this one standard form. But typically, this is called vertex form. It's called vertex form because we can clearly identify the vertex when it's in this form. So if we have a times x minus h squared plus k, the h and the k is our vertex. So our vertex of the parabola is at h comma k, where with h, we change the sign. And then our axis of symmetry here is going to be x is equal to h. Now with the next example, this one's in standard form as what we typically would call it. We can't clearly identify the vertex, so I'm going to come back to this one. We're going to talk about how we find the vertex on the next couple of slides. So we're going to come back to this example. So let's go back to example 2. So here we want to describe the graph and identify the vertex. So first, let's identify our vertex. So the vertex little formula that we use is negative b over 2a. That helps us find the x value in our vertex, or that h as what we would call in vertex form. So what's our a? 2. Awesome. What's our B?
8.
8, and C would be 7. So to find our x value in our vertex, we have negative 8 over 2 times 2. So this would be negative 8 over 4, which simplifies to negative 2. So the x in our vertex is negative 2. Now, how do I find the y in my vertex? We plug in the x. So I'm going to plug in the x. I'll do it over here so I have room. X was negative 2. So I'm going to plug in negative 2 into the x's in my equation here. So I have 2 times negative 2 squared plus 8 times negative 2 plus 7. Negative 2 squared is 4 times 2 would be 8 minus 8 times 2 is 16 plus 7. So this would be negative 8 plus 7, which is negative 1. So our vertex would be negative 2, comma, negative 1. So you use the formula to find your x in your vertex, then you plug in the x to find the y in the vertex. So our vertex would be negative 2, negative 1. Let's graph this. So we're going to go to the left to negative 2 and down negative 1. That's going to be our vertex. Does our graph open up or open down here? How do you know that it opens up?
There's no negative behind the 2.
Awesome. A is positive. A is a positive number, so our graph opens up. It's going to be a smiley face parabola. So our graph opens up here. So just a rough sketch of our parabola would look like this. It's not exact, but it'll look something like this. This is where our vertex is. We have our parabola opening up. Let's find our axis of symmetry. Awesome. Just negative 2? X equals negative 2. Our axis of symmetry goes right through the vertex. And here we go through the vertex at negative 2. It's always going to be your x value from your vertex. And then I also want to practice putting this into vertex form. So we're going to rewrite. We're going to go from standard form to vertex form. I think that there's a few questions from the homework that make you put it in one form to the other. So if it gives you an equation like this, which WebAssign will call this one, I don't know what it calls this one, but the other one, it calls it standard form. But if it gives you one, you want to put it in the form of the other one. So we're going to put it into vertex form, which is y equals a times x minus h squared plus k. So let's plug it in. We know what our h and k are. What's our h? Negative 2. So how would I write x minus negative 2?
X plus 2.
X plus 2, thank you. And then how would I do the k? Minus 1. Awesome. Now what would our a be? We can't just leave a as a. We got to put a number there. Awesome. A comes from our equation here, which is 2. So our equation in vertex / standard form would be y equals 2 times x plus 2 squared minus 1. Do we have a maximum or minimum here?
Minimum.
We have a minimum value. And what is our minimum value? Negative 1. Perfect. It is just the k or the y value from our vertex. So jumping ahead a couple pages. When we have our quadratic function written in what we call standard form, when it's a times x squared plus b times x plus c, we have to use a little formula to help us find the vertex. So to find the x value in our vertex, we're going to use the formula negative b over 2a. So where the a comes from the number in front of the x squared, and the b comes from the number in front of the x. So negative b over 2a. Now to find the y in our vertex, we're going to plug in the x that we find and solve for y. So we're going to get our x value in the vertex, then we just plug that in to find what our y value is. All right, we're going to go back to this page, so on slide 14. So to find our vertex, we use the formula negative b over 2a. So this is to find the x, or the h in our vertex. To find the y, you plug in the x and solve. Now, if a is greater than 0, meaning our parabola opens up, then our graph, the vertex is at the minimum, and our minimum value is always the k from our vertex, or the y. So it's always the k from our vertex. If a is less than 0, meaning our graph opens down, our vertex is now at the maximum, and our maximum value is, again, just the k. So max or min is always the y value from your vertex. So it says, given point B, negative 7, 3, and vertex 4, negative 1, write the equation of the parabola in standard form, which is technically vertex form. So we're given a point and the vertex. We're putting it into this form here, vertex form. But again, on the WebAssign, it'll call this standard form. But it wants it in vertex form. Well, we have the vertex. So what should I do first? I can plug in the vertex. My vertex is h and k. So we can plug those in. So f of x is equal to a times x minus h, so minus 4, plus k, which would be minus 1. Oops, don't forget the squared. So x minus 4 squared minus 1. Is there anything else that we have? Awesome. It gives us a point, which is x and y. So we can plug that into our equation, into the x and y. So our y is 3. And x is negative 7. Now, in my equation that I have here, how many variables do I have left to find? 1. I just need to find a. So if I just have one variable left, I can solve this. I can solve for a. What should we do first to solve for a?
Has 1.
Okay, we can do that. Sure. So 4 is equal to a times, what else could we do? We don't want to square root it. What else could we do?
We divide that whole thing.
Yeah, what's negative 7 minus 4?
I forgot.
Negative 11
Then
squared. I think you're thinking
and then
harder than it needs to be.
just square.
We can square it. Negative 11 squared is 121. So 121 times a is equal to 4. Then what?
Now divide.
Now we divide it. So a is equal to 4 over 121. Can I simplify this? No. Can't divide 121 and 4 by the same thing. So a is 4 over 121. So let's plug that in now. So our equation is going to have f of x is equal to 4 over 121, because that's our a, times what? X minus 4 squared minus 1. Perfect. Most common mistake that people will make on a test or quiz with this type of question is that they'll forget to put the squared, or they'll forget, I don't know, that X and Y need to be in your equation, and they'll put the numbers in there, kind of silly mistakes. But the silliest of them is that they forget the squared. So people do this whole question right and then just forget the squared at the end. So do not forget the squared.